What can you do about it? What options do you have? Anyone? Which is the same as? Reducing risk? Reducing risk? You can try to reduce it. This is called mitigation. Yes, if you identify this, you can try to reduce it. You can try to reduce the likelihood of this occurring. So, another thing you can do is ignore the risk. It is an option. Maybe it's not always a good option, but it is an option. Say, okay, I'll ignore the risk and accept the consequences when it's going to happen. Or, what I can do is, I can transfer the risk. What do I mean by that? Let's say, for example, we have a group of developers. We're developing a new application, and there is an electronic signature component that we need. Now, we have never done development of electronic signature in the company. So what we can do in order to transfer the risk, we can go to an external partner who is an expert in electronic e-signatures and ask them to implement a solution. In this way, I will transfer the risk to them. And I will have a contract that will secure it in case they screw up. I will be able to cash in on that. In testing, we typically try to mitigate risk, meaning reduce the impact, the likelihood of risk happening. And I'll get back to this in a while. Last but not least, we need to evaluate and optimize. Basically, it's not a static risk management, it's not a static thing. Once you've done a risk analysis, you need to revise it at certain phases, at certain milestones. A point which is also going to get back to, you need to understand why this is happening. So how do you identify risks? There are several methods, some are more formal than others, but basically the idea is to look either externally, meaning you look at the entire system from the outside and think, what can go wrong in this system? Or, the other way around, is inside out. Basically looking at the different features that we have. For each and every feature, you identify what is the potential risk of this feature going wrong. One important thing is risk perception is subjective. What do I mean by that? Now, from a testing point of view, you might go into a project. You think that this particular feature is very risky. Another feature might not be as risky according to your belief. However, if you get perception, for example, from the business side, they might have a different perception of the risks that you have and the importance of the different parts of the system. If you have, for example, people from support, people need to maintain it, their perception will be different. So the best thing to do is actually, when handling risk, is establishing a consensus, including all the relevant stakeholders. I'll get back to this with an example in a while. So as mentioned, we have two approaches. One is the inside out, and we have the outside in. Typically, we know that there are things that usually go wrong in a project. What are these? New development. For example, new technology, new methods, third-party components. Why is that the case? Anyone? Dependency? Because it's new, because you don't have the knowledge. We haven't done it so many times, so the likelihood of this going wrong will be higher than it's something that will be done again and again. If we look, for example, at an application, we have change areas and we have unchanged areas where bug fixes. Where do you think the likelihood of having defects is highest? Is it in the change areas or the unchanged areas? Change areas, typically. Complexity. Where do you think the likelihood is higher? When it's complex or when it's simple? Complex, because people make mistakes. They need to understand it. If they don't have proper understanding, the likelihood will go up. What about size? Something is big. typically the risk will go up. Why? Because it's difficult to comprehend when the size grows. Sometimes it might be history of failure. For example, I know from past experience that each time we have implemented, for example, an export facility in the application, we have had some issues. So this time, I'm aware of that, I'm going to handle it early on in the project. We might also have people issues. What do I mean by that? Let's say, for example, that you have a new test team. They don't have the experience. Do you think the risk would be higher or lower? Higher, because they don't have the experience. There are some other elements, for example, usage. The level of usage for the different features. Let's say we have a feature, a login feature. Do you think it's going to be used a lot? Probably yes. Everyone needs to log into the system in order to use it. There's an example of a feature that is used intensively by multiple users. So if this goes wrong, it has an impact on many users. If I also be a small feature that has financial or safety or strategic importance, for example, let's say that it's a new feature that you've been promising the entire world, the expectation is high on this particular feature, and you've promoted this, and it fails. Well, it's not the best surprise you get, is it? Dependency, what do I mean by that? Dependency can work in two ways. Sometimes you have one component that is used by many other components. Yeah? If this fails, many different components will be affected. Or it might be vice versa. It might be one component that has dependencies on multiple components. It makes it very sensitive. So meaning that any changes to underlying components will also have effect on this component. So all these factors will have an impact on the risk. Now, this is the part where I need to interact with you. Okay, let me ask you. In order to determine this part, usage and criticality, what do I need to know? And where will the information come from? Let me rephrase it. Do you think I need to speak to the support people, to the developers, or to the business? Business. Why? Because they have information about how the product is being used. Let's say I want to determine bug changes, whether it's new development, the complexity and size. Who do you think I need to speak to? Development. Very important. You have two major elements, impact and likelihood. Typically impact you get from business, from understanding the user requirements. Likelihood is often related to the implementation. You need to get information from development. Sometimes you do risk analysis without involving all parties, so you'll be missing some aspects in the risk analysis, which might lead to a wrong risk analysis. So how do we handle the whole thing? The idea is, a bit like insurance that we talked about just before lunch, is to look at all of your features, all of your requirements, and try to place them in this grid. So get requirement A, B, C, and so on. You will want to place them in this matrix where you have the impact and likelihood determined. So, let's say we have 4 requirements. Requirement B will be high risk, yes, because it has both high impact and it has also high likelihood. Risk is high, while A is low. Likelihood is low, impact is low. So you're not a test manager. How are you going to prioritize the tests? What is your approach? Where are you going to start? You're going to start here, yes? Typically, you follow an H-shaped strategy. You start up here, go down here, up there and end up with the low risk. Now the point is that if you test something that has low impact and low likelihood of failing, perhaps you don't need to be as thorough as if you're testing something up here. Does it make sense? Point is, at any point in time, you know that when you start testing, at some point, the time for testing will end. You will not have sufficient time to do all your tests. So the point is, you need to prioritize according to the risk. So when you run out of time, you have at least covered the high risk areas and potentially some of the yellow ones, and if you're lucky, some of the green ones. Okay. So let's look at how you can treat the risk. We're going to have an example in a while on this science. We're going to try to see if you can analyze an application, extract requirements, put it in the conduct risk analysis on top of that, and determine the strategy for it. So, what can we do in order to handle the risk? As mentioned, one way of doing it would be avoiding risk. If we know that certain features are too risky, we say, okay, we don't implement them. Obviously, the downside of this is that we might miss out on some opportunities, we might miss out on new markets and so on, but it is an option. Another way would be transferring, basically not spreading risk. And as mentioned before, if we, for example, have an external party where we can put the risk on, we can do that. Mitigation. Mitigation is about reducing the risk. How does it happen? Typically, you can reduce the likelihood, but not the impact. Why? Impact is determined by the intensity of use, by the number of users, by the business side. And this you don't have any influence on. But the likelihood you can change in the sense that once you've done the tests, and for example, the risky parts have passed the test, then the likelihood of a defect happening in production will be lowered because you've done the testing in this area. So the likelihood can change. Another way of mitigating the risk is using inherent fail-safe design. What do I mean by that? I'm sure you probably have seen, all of you, many of the parking houses or parking centers. Before driving down so there's a wooden bar, yes? Why do we need a wooden bar? Because typically, the height of the car is high. Then obviously, hitting the wooden bar has less impact than hitting the ceiling of the parking setup, yeah? So this is actually a warning for you that, okay, I'll hit the wooden bar, I shouldn't proceed any further. So you still have maybe some damage, but it's less damage than if you have, going into the parking house. I would say you need to be very distracted if you want to continue the journey parking the wooden bar. Okay? So sometimes we apply these kind of things to minimize the likelihood of things going wrong. Another example, credit cards. A few years back, we had credit cards with magnetic strip at the bottom, yeah? So what you used to do when you pay, swap it through. Now, you have cards with chips. How to use them? You need to insert them. What often happens now is that when you insert it, you need to enter the PIN code. Yes? So what often happens is that you forget you can't insert it in the machine. Does it happen to you? Has it ever happened to you? Anyone? You forgot to call the machine? No, you just insert it. What happens is more and more people forget the machine. So for example, especially if it's an unmanned machine, for example, if it's a parking lot or something you need to pay, you might end up getting a card in the system itself. I've done it a couple of times. Now, this is an example of something actually regressive. Because if you swipe it, you keep it in your hand. You don't forget it. But if you insert in something and you use a PIN code, you need to actually put it in the machine and keep your hand away from it. It means that the likelihood of forgetting it in the device will be higher. So this is an example of something becoming actually worse due to technology. Normally we try to do it the other way around. In software, we might want to apply some design that will lower the risk of people entering erroneous input. For example, if you have a screen with a lot of fields, you might want to gray out the fields that do not require people to enter any values before completing certain action. In this way, you can reduce the risk of putting the system into an error state. Last but not least, you can accept the risk. Okay? I know the risk is there, but it's going to happen. I'm going to accept it. What I can do is create a contingency plan. What do I mean by that? I mean having a pool of money or an approach ready if things go wrong. So if they go wrong, I'm ready to handle the risk. Okay. Let me show you an example of a metric that's often used for monitoring risk. What you see here up here are the requirements, and you see the build number. So this is basically software version coming into test. So you have build 1, 2, 3, and so on. It's coming into test. The blue one here shows the entire number of requirements. Each requirement is attached to one or more tests, yes? If all the tests associated with one requirement will pass, then you have mitigated the likelihood of the requirement going wrong. So, the risk goes down. So throughout the project, you'll be able, by doing testing, to mitigate the risk. So, another dimension we're seeing here are the risks classified according to high, medium, and low risk. What does it mean? The red ones here are the high risk requirements. These are the ones in the upper right corner that we saw before. These are the important ones. These are the ones that I want to keep an eye on, make sure that they're handled as soon as possible, prioritizing my test accordingly, and make sure that these get mitigated. The medium risk are the other ones, and the green ones are the less important ones. And to be honest, if I don't mitigate the risk of the green ones, perhaps it's okay, because the likelihood and the impact are low. Let me ask you here now, it's at lunch, I know it's difficult now, and the risk is high of falling asleep, and the impact is high when you hit the table with your head, but let's nevertheless try to see if you're still awake. What is happening here? Exactly. New requirements are coming in, which is why you have a jump in the number of requirements, the number of risks. What is happening here? Exactly. You have these scopes of requirements, which is why they're taken out. This is typically happening at the end of the project when you're approaching the release dates. You find out that certain functionality, certain features will not be worthwhile implementing, or they're too risky, or the test is failing and you'll not be able to complete it in time. You take it out of scope, which is why it's in trouble. In this situation, this is taken from a real project, you see actually that all the red requirements, the high-risk requirements, have been mitigated. So is it a good or bad sign? It's a good sign. At least I have covered all the high-risk requirements. Medium and low are still open, but this will always be the case. I've never been to any project where in a project we have actually completed all the tests that cover all the requirements. I haven't been in such a project yet. Maybe you have, but I haven't yet. I'm looking forward to that.